Hi Year 5s and happy Wednesday. Welcome to Wednesday's maths lesson. So we're carrying on with 3D shapes today, but we're going to look at making 3D shapes with nets. But to start with, there's a review task as always. So can you identify which shapes are regular and which shapes are irregular from the shapes that I've given you below? And then there's some questions or some statements to think about because the teachers have been talking again. Pause the video now and have a go. Okay, so hopefully you've remembered regular and irregular shapes from last week. I think it was last Thursday we did regular and irregular shapes. We're thinking about the 2D shapes, two-dimensional shapes, and a regular 2D shape is one that has sides and angles that are all the same. So if I'm looking at these shapes, I'll look at the 2D ones first. I can see that this is a pentagon that's made up of the same length sides, and so the internal angles would be the same as well. So I'm going to write an R on there for regular. Now here is another pentagon, but this pentagon has got lengths, sides that are different lengths. So this one is irregular, so I'll put an I over that. And we can see that they look different. Looking at the triangles, I can see we've got an equilateral triangle here. All the sides are the same and all angles would be 60 degrees. So I'll put an R on that. And we've got a scalene triangle here. So this one is irregular. Now, looking at the 3D shapes, I tried to trick you with this yesterday a bit. I wondered if you identified which shapes had regular faces and which ones had irregular faces. So we can see on the cube here that we've got regular faces because each face is a square. But if we look at the cuboid, we can see that we've got irregular faces because we've got rectangular faces as well as squares. And this one is an interesting shape. This is an isosahedron. I think you might have come across this one before, maybe not. And this is a very special shape. It's called a Platonic shape. We'll find out more about that later. And this is made of regular equilateral triangular faces. So each face is an equilateral triangle and there are 8 of them. So this shape has regular faces. So Ms. Rosenthal asks, is it possible to have regular and irregular 3D shapes? What do you think based on what we've just discussed? Well, yes, it is. We can have shapes with regular 2D faces and shapes with irregular 3D faces, 2D faces. Mrs. Bracknell says, yes, there is a type of 3D shape that is regular. So we're going to explore that in a bit more detail, but it's these kinds of shapes, these Platonic shapes. Mr. Griffiths asks, if a 3D shape was regular, would it have to have faces made from 2D regular polygons or irregular polygons? So I'm sure you have thought about that now. They would have to be 2D regular polygons. So I'm going to show you some 3D shapes on the next page, and I want you to think about which 3D shapes are made from 2D regular faces, okay? So sort the 3D shapes by whether they have faces made of regular polygons or irregular polygons. Remember, regular polygons are those sides that are all the same length and angles that are all the same length. Pause the video now and have a go. Okay, how did you get on? So I might drag my shapes. You might have labelled them with a pen or something, but let's go for it. I'll do the regular ones first. So I can see that this is a shape made of regular square faces. This one is an interesting one. This one actually would be made of regular equilateral triangles. I know it's a bit tricky to see because of the perspective, so don't worry if you didn't get that one. But this one it's made of 4 equilateral triangles. We've got this one here, which is an equilateral triangles as well. Are there any others? Yes, we've got this one here, which is made of regular pentagon faces. And we've got this one here, which is another one made of regular equilateral triangles. So quite a few regular polygons and lots of them with equilateral triangles. Irregular polygons. So we've got some regular polygons here, but we've also got rectangles, and rectangles are irregular polygons. So we're looking for shapes that either have all regular polygons or some regular, but some irregular as well. So this one, again, is a prism, so it's got rectangles, and we've got rectangles here. This one, it looks like it could be an equilateral triangle on the bottom, perhaps, but these triangular faces on the side meeting at the apex, they look like isosceles triangles to me, so they are irregular. And we've got, well, just a strange one here, haven't we, a cone. So we could, yeah, it's a strange one, isn't it? Circular face and then a curved face. So it doesn't quite fit the regular pile. Okay, so there are actually 5 regular shapes called Platonic solids. And each face is the same regular polygon. So when you're looking at the different shapes, each face of the shape is the same regular polygon, which is why it's regular. And the same number of polygons meet at each vertex or corner. So you can see here that we've got 3 equilateral triangles meeting at a vertex. And actually, if I looked at this vertex, we'd have 3 equilateral triangles meeting at this vertex, because we'd have the bottom, the side, and then the other side. So hopefully that kind of makes sense. So you can see all the different names. Oh, I actually got that one wrong, didn't I? I called that an isosahedron, but actually it's an octahedron. And now I remember why. It's because it's got 8 faces. Oct means 8, doesn't it? The isosahedron is actually here. It's got 20 faces. If you want to know more about these shapes, wait for the deeper thinking task, because there's a web link where you can go and investigate these a bit more if you've not seen them before. So we've got our other irregular 3D shapes here as well. And I want you to just think about which 3D shapes out of all of these do you think would be the easiest to make and why? You might want to pause the video and have a think about that. Okay, so some of these shapes look quite complicated. For instance, the isosahedron. Equilateral triangles are quite easy to draw and make, but if you've got 20 of them and you've got to stick them all together, that could be quite tricky, couldn't it? Whereas something like a cube or a cuboid, it's got less faces and they're squares and rectangles, so that could be easier. So we're going to start to think about how we can make a cube, and that's going to be our inspiration for making other types of shapes as well. So let's explore making a cube. Hopefully you recognize this from yesterday. We're going to need a net. So yesterday we explored how we could explode the shape so that we could see all the different 2D faces that it is made up of. And then we can think about how we arrange those 2D faces into different joined patterns called nets. And if you want to look at the nets of shapes again, or look at exploding shapes, you can look at the link. It's on Padlet. So a cube has got 6 square faces. So the net needs to have 6 square faces. And we explored this shape of net yesterday, didn't we? But I want to just show you something, because there are lots of different types of cube nets. And I think you had a task yesterday to explore the different types of cube nets. And I just want to show you something pretty cool. So if we look at all these different nets here, hopefully you can see my screen still. We need to make sure they've still got 6 faces. 1, 2, 3, 4, 5, 6. That one does. 1, 2, 3, 4, 5, 6. That one does. I wonder if you could pause the video for a moment and make a prediction. Do you think that all of these are going to end up as cubes, or do you think that some of these nets are fake? Pause the video now. Okay, so what I want you to do now is just watch as I close the nets of the shape. You can see them curling up. And look at that. Every single one of those 11 nets creates a cube. So there are 11 different possibilities. So you might want to explore creating one of those if you want a bit of a challenge later on, if you don't want to do the standard sort of net of a cube. Okay, cool. I'm going to skip ahead. So now I want us to think about different types of nets that you get. So pause the video and have a little look at the nets and what's the difference between them. Okay, so hopefully you can see that we've got the same shape of net, 6 faces, and we've got 4 and then 1 on either side, haven't we? But this one has got a little part called glue under, these extra bits added onto the edges of the faces, and they are called tabs. Okay, T-A-B-S, tabs. So I'm going to show you, I think you've probably done this before, but I just want to show you the difference between trying to make a cube when you've got tabs and when you haven't got tabs. So I'm going to stop sharing my screen for a moment. I'm going to unpin myself and I'm going to pin this, and hopefully it's still recording. Cool. So what I've got in front of me here is my net that I pre-cut out, and it hasn't got tabs on. So I'm going to make sure that I fold this so you can see how it can fit together. So basically what you do is you fold along all of the internal lines, and you've got to make sure that your folds are exact, because you want to make sure that the sides are still parallel when you've got a cube. So this side edge needs to be parallel to this edge here. Okay, otherwise it won't fit together properly. So do double check and be really precise with your folding. Okay, just going to fold this one. Now I'm folding them all inwards rather than some in and then some out, because obviously I want to fold them all in the same direction so that they're going to fold up together. So there'd be no point, you know, folding that one backwards, would there? Because I know that it needs to go over the top. Okay, so I think I folded them all, but now if I try and put this cube together, you can see that it's really tricky, fiddly, flimsy. Yeah, I can just about hold it together, but then if I wanted to stick this together, if I got my glue stick, I wouldn't know where to stick. I could possibly use bits of sellotape, but it might end up being a bit messy and a bit hard because it's all, you know, wobbling about. So now let me try it with the tabs. Okay, here's the one I cut out earlier that's got tabs. So again, I need to fold in all my lines, and you can spend some time pressing these down. I'm just trying to do this quickly. So I'll do all of these. And then again, you want to make sure when you look at your tabs that you fold along every single outer edge now where there is a tab. Okay, and it does say glue under, so I'm going to fold these in the same direction that I've been folding before. I'm not going to fold any back. Press them down. And you could be thinking, when would be the best time to put glue on these tabs? Would it be best to put glue on them now or when I've folded the shape together? Glue doesn't dry immediately, remember, if you're using Pritt Stick. You might also want to consider using other things. If you don't have glue, you could use sellotape, or you could even use some sticky labels and tear some sticky labels off, or even perhaps the back of the sticky part of some Post-it notes. Don't be limited if you don't have glue. Okay, so you can see that I've now folded all my tabs, and what I'm actually going to do is I'm going to put a bit of glue on each one now. Hopefully I won't regret this. Just because I'm using the flat table, it's a bit easier. Okay, so now I want to carefully start to bring my sides and my tabs together, and it did say glue under, and because I've already glued my tab, it's really easy to fold and stick. So here's another tab. I'm just going to use my finger of one hand to pull the tab forward, use my fingers of the other hand to just bring up the side to meet it, or the face to meet it. Just press it together for a moment. Now this is a bit trickier. I want to bring this in. Ooh. You're going to need to use a finger. Ooh, I think I've frozen. That's it. Finger to support the tab. Ooh, easy. Finger to support the tab and a finger to support the face each time. And then I think the lid is actually the hardest part. If I carefully push that down, then I can use my fingers to just guide those tabs in. And you see that that's holding its shape now. So if I wanted to, I could put an elastic band around this or something gently to just keep it together while it sticks. But hopefully you can see the difference. The tabs make it a lot easier. Okay, I just want to show you this actually as well while I've got the camera on, because this was the box that I was showing you yesterday that I had trouble sticking my Post-it notes to. I'll just fold it up quickly. It's my tea box. Okay. And you might want to do this, like I suggested yesterday. If you see if there's a box that you can ask permission and unfold, when you actually unfold it, you'll be able to see the different faces. So I know a cuboid is made of 1, 2, 3, 4, 5, 6 faces, but you can also see that this box has been made using tabs as well. Okay, so it's the practical way of creating 3D shapes. Okay, super. So I'm just going to unpin, repin myself and share my screen again. Super. So guided practice, what I'd like you to do is try out some of the cube nets below. Do you think they will all make cubes? Now I haven't given you any tabs on here, so you might want to think about where you can add tabs. Remember that when it was picture 2, we had tabs sort of at the edges, didn't we, here? So I had a tab there, and then I had another one here, and there was another one there, there, and then at this end, one there, and then one there. Okay, so it will be helpful for you to think about the placement of tabs. That might help you out. Don't worry if you try it out and you end up with something like this, because it's just about giving it a go, okay, having the experience. In your independent practice next, I'm actually going to be a bit more generous, and I've given you nets with tabs. So don't worry, you will be able to make a net of a shape and be pleased with it. Just have a go at trying the different nets now and trying to put on your own tabs. Okay, pause the video, have a go at that. And then when you've had a go at your guided practice, move on to the independent practice. So today's independent practice, as I've just said, is a practical task. You are going to make 3 separate shapes from the nets that I've given you on the next pages. I want you to make 1 prism, 1 pyramid, and 1 platonic solid. You can make more if you want, but I want at least 1 shape from each of those sort of categories. I've purposefully not labelled the nets on the next pages, so I do want you to think, oh, which shape has she given us to choose from? Look at the shapes' faces and use your knowledge of 3D shapes, okay? Have a think about that. And if you have access to a computer and you want to choose from a wider range of shape nets, please go to these websites, because you can print another net off for free. So this is funstufftodo.com. That's where you'll find lots of other 2D shape nets. And this one, mathsisfun.com, this is where you'll find more platonic shape nets. Okay, so you'll see you've got some prisms to choose from, some pyramids to choose from, and some platonic solids and non-polyhedra. Okay, so a non-polyhedra, remember, is where you've got one of those curved faces. Finally, there's a deeper thinking challenge. So I hope you enjoyed today's practical maths lesson. Please take pictures of your solids, take pictures of the nets, send them into year 5. We'd love to see what you've been up to. Okay, guys, bye.